All right, I think we're good to go here. We're shortly after 9 a.m. So yeah, thanks everyone who's already dialed in here. This is our first Data Science on AWS Meetup in 2023. We're super excited. We just set up the whole series. So if you haven't seen it yet, we're back in action here. We run those meetups every month on the third Monday. If this is the first one, yeah, we've been just chatting about books. Chris and I, we've written a book as well with O'Reilly, Data Science on AWS, which is available. We're just working on a couple more translations, so that's super exciting. Yeah, which languages did we publish last year, Chris?
Oh, I lost track. I know that the Russian one is no longer being done, so happy to hear that. Yeah, Antje, can you zoom in quite a bit, by the way?
I can.
And I think overall, what we have Spanish, we have Korean.
We don't have Spanish, we have German.
German, okay.
We have Polish, and we have simplified Chinese. And we have a Korean edition about to be released. So they're just doing the final touches on the Korean translation as well. So if folks are interested in any of those languages. All right. And as I said, Chris and I were running those meetups here every month. You can see them. We're posting about it. We'll share the links here, and you're joining us today, so you found it already. But yeah, come back. We're posting the agenda for the next couple of calls here soon. And today, I'm super excited to have Adi Polak with us here. She's going to talk about Git for data with LakeFS. I think that's broadly the topic, chaos engineering in the space of data and how you can manage data stages in large-scale complex data flows. Adi is the VP of DevEx at Treeverse, and she will explain a little bit and introduce herself in a bit here. And then for the second part of today's meetup, Chris and I will give you a quick recap of the AWS reInvent highlights for AI machine learning. For those of you who don't know, AWS reInvent is the big developer conference every year that AWS hosts in Vegas. And we do have a quick summary of some of the highlights, the product launches that happened there, specifically in the data AI/ML space. Yeah, anything else to add, Chris?
No, I think that's good. I'm just slamming a bunch of links here into.
Perfect. And with that, I'll stop my screen share and hand it over to Adi. Adi, thanks for joining us today. Super excited about your talk.
Yeah, absolutely. Thank you so much for having me. It's super exciting to be here. And I have a copy of your book, which I love. So thank you so much for writing it and putting it together. It's exciting to see the different languages that you're now translating it to. I'm sure it will make a lot of people happy. And many of them are going to, get advance in their work, essentially. I think it's really critical to stay focused and continue learning and reading and, expanding our skills. I guess, so Antje and Chris allowed me to share my book as well. So let me do that. I wrote a book about machine learning at scale with Spark, and specifically dives into the topic of what are the different technologies that we already have on board in our organizations and how we can take advantage of them. And oftentimes, many of the technologies that are already available is actually Spark. So it's really interesting to be able to take advantage of that and get the most out of it. So if you're interested, you can head off to AWS, Amazon website and get the copy there. It should be ready for you in print in just a couple of weeks. All right, and we'll share the link later on, so you won't need to find it or search for it yourself. Let me share my screen and we'll start. Right. Awesome. So I don't know if you remember, some of you are building ETLs or building different platforms for data. Some of the things that always happen to us is that our system doesn't always behave the way we want them to behave. And there's a lot of reasons why this is happening. I really love this quote from Holden that said in 2017, don't make assumptions about things in Spark. Like don't assume the Spark just works and it's going to produce the same result over and over again, because under the things or under the hood, there's going to be some unexpected things that we cannot foresee. One of a good example is actually the new query optimizer. Starting with Spark 3.1, the new query optimizer is not static anymore. It actually changes the query planning on the fly, giving statistics about the data. So for example, it starts on query stages and then it continues to optimize. So the more we work with these different platforms, the more we work and embrace distributed systems to process our data for data science, machine learning, analytics, the more unknown is going to come up. And the same thing we see with TensorFlow, the distributed TensorFlow, distributed PyTorch, and many other tools. So today, I'm very excited to speak with you on chaos engineering in the world of large-scale, complex data flows. What does it mean? What we can take away from chaos engineering? Chaos engineering is a topic that comes from DevOps world. So if you're not familiar with that, don't worry, we'll dive into it. And we'll dive into it and we'll see what we can take away out of it when we're working with data. Some of the personas here will refer to them as data engineers, some as machine learning engineer. But at the end of the day, when we're building the infrastructure for our ML, we also deal with data. So we always need to kind of manage all these skills together. I'm available on Mastodon and Twitter. You're most welcome to send me a private message and connect. I always like to meet people and get your feedback. All right, so what can go wrong with data flows in production? Essentially, everything. We can have new component logic that we push. We want to change some legacy code. We want to move some things. We want to introduce new data sources. Many times we want to enrich our data, right? We want to add more and more data sources that comes in on the fly. A lot of machine learning system needs to handle more than 30 or 40 new data sources coming into the system. Sometimes depends on what it is that we're doing. We need to handle incompatible schema changes. And this can be really, really painful if something, our system works really well, our pipeline are well constructed. And now we have some change in the whole flow, and we have to handle that interface again. Many times Spark jobs run twice, can run twice in parallel, can change some of the data. It can become corrupt at the end of the day. Sometimes we want to change just the table relationship, right? We're doing some join, we're doing some enrichment processing, we're doing pre-processing on top of the data, and we want to run these joins. And so we might have broken the data, and we'll see a demo later on how easy it is to actually break our schema and relationship keys. Or, we just accidentally deleted, there was a retention job or anything else that happened and we deleted data, or we created data duplications. So many times we say, okay, so we should be able to test our workflow end to end. I want to know how this system that is now supporting my customers is behaving behind the scenes. And Matt Ryer tweeted a while back a really interesting statement around disagree and commit. He essentially said, I practice disagree and commit. I disagree with failing test and commit the code anyway. Because many times it's really hard to understand what really failed, right? We have unit testing, we have integration testing, we have system testing, we have end-to-end testing. All of that different testing suites supposed to help us gain confidence in our code, in the changes that we just introduced. Yet it's sometimes so hard to even build those tests that we just, test in production. That brings me to the principles of chaos engineering. And chaos engineering discuss different principles, with the first one being steady state. A steady state says that I know what is the happy state, what is the good state of the system. For example, I know what I need around system throughput. This is what I'm looking from a DevOps point of view. I know the error rates. I know the latency percentiles. all of these things. This is my happy place. This is the state that I want to reach constantly and want my system to be at. From a data point of view, that means that my data products need to have a specific data quality. It doesn't have to be good. It doesn't have to be 100% accurate. You will see that sometimes 70% accurate is sometimes good enough, especially when we work with a lot of data. But we need to be able to define it, and we need to be able to be specific about that. So specific data quality, sometimes no duplications is required, right? If I'm doing like bank transactions or things like that, I don't want my bank to charge me twice, right? For the same charge, essentially. And I don't want it to duplicate it accidentally. And these things happen, right? So I want to be able to be conscious of that. And then I need to work with some SLA, some time until people getting the insights, the freshness of the data, and all other things. And you're probably curious to know how easy it is to actually mess it up, right? So here is an example of how in just 3 lines of code, I duplicated the data. And I'll give you a second to process that. And now let's go over it together. So the first line is I'm reading a data frame using Spark API, right? I'm giving it some Parquet file. My data is on S3, and I'm reading that specific transaction. Later, I'm doing some update to the data, some transformation over the data related to finance. And then at the end, I want to write it back. I'm writing this data back with the same timestamp because I just wanted to update a couple of the rows there. And what I do here on the write mode, I'm calling append. And append, what it's going to do at the end of the day is going to append the rows to my existing files. So this is how easy it is to duplicate data. Just this append. And many times under the hood, when we're digging into our software, sometimes this writing mechanism will be hidden from us. Sometimes we have full control, sometimes these will be hidden, but at the end of the day, it creates that data duplication that it's very hard to recover from, because this is a Parquet file and we have to go back and revalidate that our data is right, that we remove duplications and so on. So like I mentioned, first principle, steady state. Very hard to make a mess here and create data duplication, just as an example. Second principle of chaos engineering is acknowledging, this is the hard part, that real world events are usually very different than our happy state, than the state where we want to be at. If you look at the classic, usually it means hardware failures, server dying, spike in traffic, different things like that that we cannot really predict, and things that we need to be able to take care of and have failure mechanism that where we know how to bounce back, that a system knows how to bounce back. In the world of data, there's a lot of events that can happen, like schema changes, something I'm pulling some data from one of the data sources, HubSpot, Facebook, LinkedIn, no matter what it is that I'm building. But let's say I'm pulling in some data and whoops, they changed the schema, they changed the API, something there is different. So it might be that now what's happening in my production system that I'm pulling in data with different schema. It might be that accidentally some of the operations created corrupted data records. And that happened a lot, especially when we're trying to drop data, add data, do some join operations. It happens a lot that accidentally we introduce either corrupted data records or null values into our system and so on. Data variance changes. If I have a machine learning running in my production, it might be that it suffered from data drift, model drift, things like that that I need to be able to take into consideration that are different than my real world event. And like we mentioned before, it can be that I accidentally deleted some data and I need that data for my features. These are actually my features there and I need to pull them. And now I'm in trouble because real world is kicking in, and this is what happens. And so while I really wanted to enjoy the upcoming weekend, I'm actually in a place where I need to deal with production incidents, data errors, or anything that comes in. This is not fun. Another great principle of chaos engineering is accepting running experiments in production. So if you remember, we talked about disagree and commit. I disagree with the test and I push them anyway. Then the next stage is actually saying, if it's going to happen anyway, I should make my production super resilient so I can run experiments in production and bounce back when I need to. So this is where this principle kicks in, is acknowledging that we're going to run experiments in production. And if you've been trying to do that, you know that many times we're not really trying to run experiments in production, we're trying to build tests. But essentially, at the end of the day, all of us are running experiment in production. We're running our tests, we're gaining some confidence, but then we're pushing it and we're like, oh, I really hope this will work, right? And so sometimes people wake us in the middle of the night. We're like, oh yeah, I did change something in my ETL. And now, yeah, it was kind of an experiment. So this is one of the core principles of chaos engineering as well. And we understand that when we talk about DevOps, this is usually the machines, the networks. These are the things that we experiment with, the configurations, different security, access mechanism, etc. Versus in data, the things that we deal with is production data. It's probably one, very valuable asset that we have. That on top of that, we're actually creating value for our customers or downstream, inside the company, downstream customers. So it happens a lot. So we acknowledge that we need to build some experimental environment. We want to be able to experiment on production data within our production. And that touches a little bit of some of the solutions that we're going to see today, that when I'm thinking about my production data, I can essentially think about it as my main pipeline, where data is streaming in and being exposed downstream to my customers. And once I have this in mind, I can always branch out. I can create an experiment environment that is a copy of my production environment, of my production data, and then test my code, test the changes, see how things progresses. And this is something we do often. Oftentimes we go and we copy all of our production data for experiments, for testing, for building models, for different things that we need to do. And well, this is great. It can be sometimes costly. It's costly because copying large set of data takes a long time. Even when we use great cloud services, it can take very, very long time to copy all the data. Sometimes we get exception like rate exceeded because, someone else is trying to use the same resources, or we're getting back an exception. So this is how sometimes the cloud providers balance the different resources. And that process can be very painful, although we know we definitely need that experimental environment. Also, if you've been working in different organizations, you probably noticed that there are some companies that actually build their own experimental team. This is the team that's responsible for the infrastructure to enable experiments on top of production like data, with production like environment, and so on, in order to expand and grow and reach the next level and really dive in to understand what can be valuable for their customers. So what we see here is that we take the S3 URL and we change it a little bit. We create, and within our bucket, we create another directory where we copy all our data to. We can use it with LakeCTL. We'll touch on it in a bit. The first principle after we acknowledge that we are anyway doing experiments in production, so now we want to be smart about it, and we want to do it mindfully, is being able to automate it. So we are able to run experiments in production continuously, while being able to minimize the blast radius of an experiment. If an experiment fails, it doesn't mean all my production is down, right? I have some recovery mechanism and I'm able to bring it back. So in the DevOps world, this is the chaos monkey. And the goal of the chaos monkey is to discover weaknesses in the system. Chaos monkey was developed at Netflix. And what it did essentially is disconnecting some of the machines, disconnecting the network, killing some of the machines, and really diving into the fault tolerance strategy or mechanism to better understand how machines can bounce back and recover from failure. So if this happened, their customers are not going to have an outage for a very, very long time. And so this way, in that way, they discovered all the weakness or most of the weaknesses in the system. You can never really discover all the weaknesses, but you can definitely strengthen your system by discovering the weaknesses and fixing them, building mechanisms that are able to create more tolerance, build more durability inside the system. So while this is really nice for DevOps, where we can pull the plug and disconnect the network, for data folks, that means we need to better manage the data lifecycle in different stages. And for that, we need to take a look into what are the different production data, what are the different stages that our production data usually go through. So usually at a very high level, no matter what it is that we do, we have ingest. We always need to ingest data into our system. We need to drop it in our bucket, drop it in our SQL, in our database. No matter where, we always need to ingest data. And that can be multi-data sources that we're ingesting into the system, handling different format of data that we're ingesting, throughput, latency, and so on, depending on what it is that we're doing. We need to process the data. We might have multi-joins, cross-table transactions, different analytics that we're running, enrichment on top of the data, different processes that brings the data from a raw state to a state where it actually brings value to my customers. And usually the last stage is where we're exposing the data, either some UI, either some actions that we take based on the data, analytics, machine learning services, models, microservices that use the data and need to consume it downstream. All of these different customers that are potential customers for us that really cares about the materialized data at the end of the day. So the question is, like, how can we automate this moving between different stages where we're adding different logic, where we're creating different things and propagate it in our production? So this is what I want to bring today, or at least one of the things I want you to take away from it, is how we can build essentially that continuous integration, continuous deployment of data. And that's building the guardrails and building the whole system and process around our ETLs in production in a way that enables us to manage that data lifecycle in a secure, durable way. So here you can see, for example, that if I have my main branch of data, my main pipeline of data where data is streaming and being exposed and being processed, if I have any new feature or some process that I want to do to the data, I can go back to my copy, do that processing. If I'm happy with that processing, I can merge it back to my production mainstream of data and say, okay, I did some of the processing. There's no, schema changes. The system is good. The data has the quality and accuracy that I'm expecting. And so I'm merging it back into the data that can be exposed downstream. Here you can see some feature branch. So we're adding new data into the system. And on merge, we want to test if we're running a pre-merge hook. This is a web hook that enables us to check the type, the format of the data itself. For example, we're allowing Parquet, but we're not allowing CSV. And so because we're not allowing CSV, all that merge is going to be declined atomically because something along this line introduced a random CSV, and I need to go back and revisit my code, revisit my environment, or better understand what happened there. So here, this will not merge. And in order to be able to do that, we need a mechanism that enables us to copy that data in an automatic manner that enables us with these experimentations. And this is very, very similar to Git that enables us to do version control on top of our software. So we can do the same thing for data and have version control for our data lake, so for our S3. And that enables us to, if we dig into it, because of all this mechanism, we can recover from error. Because if I'm using Git, that means that I'm doing some commit operations. I changed the data, I committed, I said, okay, something got changed in my data, and that means I can revert to the previous version of the data. I can develop in isolation because each one of my branches are separated from each other. I can troubleshoot. If I had some production data, I accidentally, somehow along the way exposed bad data downstream, I can revert, right? And because I can revert, I am able to start troubleshooting and only look at specific commit that introduced the problem into my production. And this is extremely useful tool because let's say that happens to me on a Saturday, I can revert, having clean, healthy data exposed downstream to my customers, and then only on Monday start investigating the problem. So that gives me the time, that enables me the time and space to really understand what the problem was while my customers are still happy. That enables me also the atomic update. Like we talked about merge, if everything passed the test, then we're merging. If not, then the data is still on its own branch. So this is the atomic update where I'm doing update for all my bucket or all my directory, depending how I'm doing the branching mechanism. And another one is reprocessing. I want to be able to take the same data, but change the logic, right? Many times we want to collaborate, multiple people in the team want to take the same data, want to do copy of it, and want to start reprocessing, or I have multiple models that I'm producing on different branches with different data. And then I want to be able to merge only the one that gave me the good results. For example, if I'm testing different features and so on. And you probably say, but this is all great, but this is very expensive because then it means I'm going to copy my data over and over again. And that can be really, really pricey, especially now when I have this automated process to do so. And so that brings me to the open source project that I'm working on, LakeFS. And LakeFS under the hood has a special data modeling that enable us to do copy on write. Copy on write means that all my copies of my main branch, my main repository, are zero copied. Zero copied, that's because they are only pointer based. So they are shallow copied, they hold pointers to the actual files. Now, if I introduce the change, let's say I have 1,000 files, and I introduce the change to only one of the files out of the 1,000, instead of having 200,000 files because I copied it once, now I'll have 1,001 files because I introduced change to only one of the file in one of my branches. And so this is only when copy and write is actually going to start happening. And this is really interesting statistically, because what we've seen with a lot of our users when we ask them is that oftentimes they only really copy, like change, 20% out of their data. So instead of holding real deep copies, like 10 deep copies of my data, I end up, with having 1 point something copy of my data, which makes it very cost efficient in time and in money, because copying the data also takes a long time. So that's a really great advantage. And copy and write mechanism is really helpful because I am able to travel back in time and I'm getting the experience of a real copy, but under the hood, it's zero copy. So I'm getting all the benefits of all the worlds. And you're probably interested about what does a typical environment look like. So there's a lot of ways of how we can go about the environment. So this is only one example where I have my main branch of data. This is my production data. It's well protected. You can see I have a lock around it. I might have added policies or access control, or all this big fancy names to basically say only specific users can actually merge, only giving us on specific rules. And then I have my dirty ingest branch. So I have new data getting into the system, and I'm testing everything to see how my logic works together with the dirty ingest branch. And on the merge, I can decide if I want to merge it or not. I can continue doing different commit. I can have on the bottom, you can see my dev experimentation branch. I could have many experimentation branch if I wish to, and here only do commits and validate the experiment output without merging it back to my main production. And this is really useful, especially when we want to do some analytics. We want to train a model. We want it to be trained on real production data because we don't want to suffer from data drift, or we don't want to sample that data specifically. So we want to run, we want to train, we want to get the result, and then we want to make a decision what we want to do about that. That can be really, really useful for me, where I have my development experimentation branch there. And many other where I'd love to show you a demo. So let me share my screen just a second. And so my demo is the demo that we're going to see today. I'm going to run it on a Databricks environment on my AWS cluster. So I'll just start my cluster, confirm. And I'll go back here. All right. Before we'll start, I want to show you how LakeFS UI looks like. It's probably very, very familiar to you, especially if you've been working with things like Git or GitHub. I have my repositories. Here I have all the different data repositories that looks into my S3s, for example, an EMR demo that I did together with Airflow. I was directing it into my storage on S3 specifically. Here we're going to look into this fun thing where I'm having, this is my repository. This is specifically a D 2022. I can look into my branches. I see I only have one branch of my data. If I want to create a branch, I can easily do it from here. And now I can go into my branches and see the different data that's available here. One of the things I want you to see is actually that the files are not different. So if I'm doing a compare and I'm comparing my experiment to my main, there are no changes because I didn't introduce any changes. This is a zero commit mechanism. You can see how fast it took me to create the actual branch. And this is the area where I can start working on. So let me just delete that. One of the nicest things around LakeFS is you can work with the CLI. You can work with the LakeFS client. You can work directly from the UI. So it makes it very easy for us to build an environment that incorporate it inside. All right, so my cluster is starting. This is a Databricks notebook. I'll make it a little bit bigger. I hope you see it. Well, see, that's just. Yeah, and of course, if you have any questions, feel free to ask. This is your time now. Definitely makes the most out of it. All right, so my cluster is starting. Let's give it a couple more seconds. And Alrighty. Ooh, another thing that I wanted to show you while my cluster is starting, this is the libraries. So to start working with LakeFS, you'll need to install the different libraries on the Databricks cluster. One of them is the LakeFS assembly that I'm going to use. I'm going to use the LakeFS client. This is a Python client that enables me to create a client to work with directly from my code programmatically. And lastly is the LakeFS FS, so LakeFS Spark client that enables me to create higher performance for working with S3. And this you can download from Maven, this you just add the library, and so this one as well. So while this cluster is starting, let me go over the code together with you. So creating a client, it's very easy. All I need to do is give it the configuration. I'm giving it the configuration, I can create my LakeFS client. Later on, I can, once I have my client, I can look at all the branches programmatically. Here we go. I can look at all my branches programmatically directly from here. And then I'm getting a message back saying, how many branches do I have? So here I have some commit ID, and ID is the only branch that I have. This is the main branch. Next, I want to create a new branch. And so I call create branch. I say which repository. I say which the name of the branch that I want to create and what is the source. I see I have some command failed. I guess what client here we go. Yes, I need to do this first. And this one. Awesome. Let's look at the list of branches. And like you've seen before, I only had one branch. Let's create another branch. Let's do it programmatically now, right? So I'm calling an experiment branch, and my source is me. So again, this is a zero copy mechanism. And here you can already see, I'll do a refresh, and you can already see my experiment branch that I created programmatically. I'm defining a couple of variables because I need them. And I want to see the difference in between these two branches. I get an empty list. That means there's no difference between the two. That's great. All right, now to my data. I have two data sets. One is genres. The second one is books. So you can imagine, we're going to do book genres. So this is going to be a lot of fun. So I'm going to read my genre data frame from Spark. And remember, this is reading actually from the LakeFS branch, which under the hood has S3. So I'm reading genre DF, and I'm going to read my books DF. And let's compute that again. I want to take a look into the books. And because we talked a lot about books today, let's look at some of them. Fundamentals of Data Observability by Andy. Designing Data Intensive Application by Martin. A lot of known and loved books. Project Metadata by Catwoman. I can't say all the books are real, but just play with it. And Scaling Data, let's say Data Science Platforms by Gamora. Let's see if you know who this one is. So now we have the book and the book authors. Now let's have a look at the genres themselves. So I'm running it. I'm seeing High Performance Yarn. It's a fiction. Reviving Zookeeper is drama. Hello, Spark fans. This is a classic. A lot of people are using Spark, and so on. Not going to delete it. This is not needed. And also this one is not needed. This is a Hive operations here that I'm skipping. And one of my assignments is actually to join these two tables. I want to have my genres and my book and my authors all in one table, because this is the table that I want to ingest and I want to start working on. So I'm doing a left join here. So on books, on my actual books, checking if the serial number of genre is similar to the serial number of books, and this is how my join is going to take place. And you probably have, all your cheat sheet around join, and you know how things are working, and no one is really remembering it by heart. But I do want you to think about left join specifically, and we'll get back to it in a second. And I want to save the data that I just created. And look at this.
Just a quick timing. So can we wrap in like 3 minutes?
Yeah, of course.
Perfect.
Looking at this, I know I write it directly to my LakeFS experiment, and I can do the compare. So here, when I'm comparing this, I can see that there was already, sorry, I didn't commit it, but I can see that there was already some changes that I introduced into the system. Okay, I'll skip that commit, but we'll get to it in a second. What I do want to show you is an interesting part is I just introduced some null into my code because my join was wrong. I did a left join, I had some problems, and so I want to run some quality checks on it. And this notebook is going to be available for you to use it as well. And this query gives me all the null that I have in my data. I have probably some null in authors, in name, and in my ISBN. I can also do some quality around count, around display, and so on. But now I know that I have all these problems. So I want to go back into my branches, and I want to make some conscious decisions around this thing that got changed in my data. So I can go into here, sorry. And I can make some conscious decisions about what happened when I'm writing my data. Sorry, for some reason it jumped. I think I missed a couple of commands here. But what I can do, I can actually change my join. I can create another version of my data, change my join, and run my quality assurance again and see that here, all null values move to genre, which is something I can fix and I can correct because I can give it some random genre if I wish to. And now I know my data is in a much better state. I can fix it. I'm running on my experimentation, so I'm not harming any production data. And so if I accidentally introduce some bugs, I can always recover back. All right, and I know we are very close to time. I'll just say a last couple of words. First of all, thank you so much for listening. I hope you learned something new. And if you have any questions related to LakeFS, Git for data, data version control, all of this good stuff, you're most welcome to ask. And I'll just share, if you want, you're most welcome to give it a try. We have LakeFS available on GitHub, and we have a lot of interesting users that use us and contribute back. Yeah, and I would really appreciate your comments, and would love to know what you think about it and how do you see it in your technology stack. Thank you.
Perfect. Thanks so much, Adi. Really appreciate your talk. It's a great view on how we can manage data and on a whole Git for data approach. We do have some questions coming in the chat. Due to the timing, it would be great if you could answer them in the chat. And Chris and I will jump to the second presentation for today. Thanks so much, Adi. Really appreciate your time.
Thank you so much.
Great to have you as always. All right. And with that, Chris and I will go ready. Adi will answer questions if you do have more questions for Adi in the chat. So feel free to post them there. And let me just start my screen share. Getting my environment ready here. And maybe Chris, you can start with a little bit, maybe recap, a couple of thoughts.
Yeah, so the reInvent conference happened, I think it was the week after Thanksgiving, as always. Two of the biggest themes, I think, for this year or for 2022 were better Spark integration throughout the entire stack, not just SageMaker, which is the service that Antje and I support mostly, but through Athena now has native Spark support. And also it's worth noting that all of the Spark implementations now share the EMR Spark, which has been there for quite a long time, since the very beginning, sort of early days of Spark, and is very highly optimized for AWS. They've all been upgraded to, I think, the latest 3.3 Spark, and that's a big one. And there's one other theme. You'll cover it. Yeah, why don't you go ahead?
All right, so let's dive into it. And just a disclaimer, this is going to be a news flash, so we're not going to go too deep into every launch, but just give you a broad overview. So it's going to be a little bit of a quick go through here. All right, so to start with, just a quick reminder that all of the machine learning launches, the machine learning services AWS offers, it's really part of a larger toolbox, right? Think of AWS and the different services as a toolbox for you to start building your end-to-end ML and data applications, pipelines, etc. So this is really kind of a bigger slide here that shows there's a lot of tooling available for you to store data, of course, whether it's in databases, whether it's in a data lake on S3, and then tooling to query the data, tooling to integrate, and then obviously in acting on data, this is where machine learning comes into place, but obviously also any kind of business intelligence services, etc. So this is really part of a bigger portfolio. And today we're going to focus on the highlights specifically in the machine learning space. And as a rough kind of categorization of the different services and offerings AWS has, we tend to organize it in 3 different layers. And you can see here at the bottom layer, it's around the ML frameworks and infrastructure, so new instance types, new GPUs, custom silicon developed by AWS, etc. And then what we group in the second layer here in the middle layer is the tooling around Amazon SageMaker, which is our end-to-end machine learning service, which helps you now to give you a quick start really in building your machine learning pipelines. You don't have to build it yourself. It is available. Mostly what we're using as part of SageMaker Studio, an integrated IDE that helps you preparing data, creating and storing features, and then building training models and deploying them. And then on top, AWS also offers pre-built AI services that are ready to use in different domains. So for example, like text recognition, text extraction, speech, vision, and then also more specialized, maybe conversational AI, enterprise search, etc. And again, in this recap, we're mainly going to focus what is more like what ML practitioners work with. It's in the middle tier, Amazon SageMaker, where you're building your ML applications. All right, let's dive into it. So a big theme during reInvent was also how can we improve machine learning governance? And machine learning governance obviously is very important, and it spans a couple of different stages. So it starts here, what you see on the left with onboarding new users. You want to make sure if you onboard users to build machine learning applications, pipelines, models, etc., they're working with just the right set of permissions they need to accomplish their job, right? It's how finding that permission set that it's not giving them too much permission to do stuff, but just the right amount. And we simplified that. I'm going to show you here in a bit. Then you develop your model as a practitioner, and you also want to be able to kind of describe the model purpose, track model details, information, what data set has been used, to kind of, contribute to the overall governance piece. And then when you deploy the models, you also need to be able to monitor them and make sure they're behaving in the right way you expected them to do. And obviously this spans a lot of different personas too. So how can we simplify this? And AWS launched 3 new capabilities during reInvent, which are generally available right now. It's Amazon SageMaker Role Manager. And this is really kind of a tooling on top of creating, permissions, onboarding users. So with a couple of clicks, you can define the user permissions in a couple of minutes. You don't have to dive deep into the IAM service or anything. You can click, and I'll show you here in a sec how that looks like. We do have SageMaker model cards. It's a term used in the data science ML space already. And this helps you to document model information. So what I said, like the purpose of a model, data sets used, expected use of the model. And then we also launched as a third part model dashboard, which is kind of a central place to monitor all of the models that are deployed. And we'll see you have monitoring options. It tracks if the model is monitored and can create alerts, and also tells you if it goes off specific baselines or expected thresholds you set. And let's have a quick look how this UI looks. So in the AWS console, if you're familiar, if you navigate to SageMaker, you will see a couple of different new items. One is under Getting Started. You will have access here to SageMaker Role Manager. And if you can see here on the screenshot on the left, it's a step-by-step configuration that walks you through a couple of those important decisions. So you can start actually with a persona type. So for example, there's a persona type called a data scientist or an MLOps engineer that presents you kind of a couple of pre-selected permissions that, usually those roles have. You can customize it, of course, and you can create your own personas. But basically, you're defining this role, let's say the data scientist in your organization. And then you can see here how you can configure specific activities. So what should this data scientist persona in this case be able to do, right? For example, run SageMaker Studio applications, manage ML experiments, manage ML jobs, etc. And you can customize this to your specific needs. And when you click OK at the end of this guided walkthrough, it will create underneath the respective AWS IAM, the identity and access management policies and the roles. And you can then, when you onboard users to SageMaker, select that IAM role, and all of those permissions are in place. So this is really to help you simplify creating those permissions. Then here is a screenshot of how those model cards look like. You can define here the intended use for the model, training details, data sets used. You can also document the evaluation when you check how the model is performing, attach those evaluation results, attach any additional details, notes you want to put in. And then you can use those model cards and you can share them with different teams, maybe business stakeholders, maybe internal teams, internal colleagues, or even your customers if they ask about this model in terms of kind of, the governance piece. And then we do have the model dashboard now also, which is a central place to monitor all of your different models that are in production, that are deployed and serving inference. And you can see here, you can give it a risk rating. This can be based, on your industry, on the purpose of the model. You can attach monitors that monitor the model quality, the data quality, if there's any bias drift. So this integrates with SageMaker Model Monitor for that purpose, and with our SageMaker Clarify tool, which helps you to, check for any bias, for example, or feature attribution drifts in the model. And it will show the results here on this dashboard. All right, this was quickly on the model governance. Again, this is going to be a quick walkthrough today. Now let's jump over to the data space. And I do have a couple of updates here in how you discover data, analyze data, and prepare data. Chris, do you want to talk a little bit maybe about the data zone, and I flip here through those slides?
Yeah, I think let's just skip through. We only have about 4 minutes. We will continue recording and we'll paste it. But maybe let's zip through what's after the data zone stuff.
Yeah, I have a little bit on Data Wrangler and Glue here. So let me pick a couple of them. So I'll do just a couple of the highlights here to be aware of the timing. So Amazon Data Zone was introduced at reInvent. It's not available yet. It's coming soon. So stay tuned. Data Zone is a new service, and you might have heard of a new concept in the data space called the data mesh. We had some presentations here in our meetup as well last year on the topic where you're treating a data set as a data product, and you're building up an internal kind of a business catalog in your organization, maybe kind of even like kind of a marketplace. And you have data producers, those are the teams that generate the data sets, and you have data consumers that want to use the data. With this new service, it's going to be kind of, an integrated platform that simplifies that setup for you. So this is super, super exciting. With obviously controls to manage the data, to govern the data, and then for the different teams in your organization to discover them and make use of it. So super excited, stay tuned. I think the preview will launch very soon. All right, and then just here, SageMaker Data Wrangler is part of the SageMaker platform of services. And this particular feature here is super, super interesting. So when you're in your Jupyter Notebook environment, you can now do in Notebook data visualizations on top of pandas data frames. So with 3 lines of code that I show here on the left, import pandas as usual, and then you can import now SageMaker Data Wrangler, our data prep tool. And this will visualize as soon as you do pandas data frame, like you read in data, for example, here, CSV file, and you show it like you print a DF, it will analyze each column in the pandas data frame and gives you recommendations, analyzes the data. Hey, there is missing values. Hey, there is a wrong data distribution. It identifies data quality issues, and you can, in the notebook, click and apply suggestions to address those data quality issues, and it generates the code for you in the notebook. So really, really interesting. Let's just do this one more, and then we jump into the SageMaker. Chris, do you want to talk a little bit maybe about AWS Glue for Ray?
Yeah, Glue for Ray, pretty awesome brand new addition to Ray. So Ray has, to Glue. Glue has always supported Spark for a very long time. Earlier in the year, last year, 2022, I think it was around July, there's something called Glue Interactive Sessions, GIS is what we call it internally. And that also supports Spark, and now also supports Ray. So you can essentially, and from SageMaker, you can actually open up these Glue Interactive Sessions. And we've been running, very, very large data set transformations using Ray and Glue through SageMaker. And we've also been training models like XGBoost and PyTorch and TensorFlow and all the things with this combination. So check it out. Yeah, Ray's a really cool project. Very much reminds me of the early days of Spark and is maturing very quickly. So we'll have, probably 3 or 4 more sessions this year on this meetup on Ray. We talk about it all the time now.
And let us know which topics are of interest for you, and we'll dive in one of our next meetups here into those. All right, let's switch over to building and training ML models. Super excited. First of all, which is kind of just a UI refresh announcement, but I think it's kind of impactful because if you have been working with SageMaker Studio before, the UI wasn't like that intuitive as we would love to have it. And we now did a complete UI refresh. So if you have been using Studio in the past, you will notice this hopefully when you log in. Make sure you're on the latest Jupyter Lab version 3 or later. And what you can see here, complete UI refresh. On the left, there's a menu now that shows you, more aligned towards the ML workflow. So starting working with data, running auto ML experiments, tracking ML experiments, creating pipelines. So it's a little bit more intuitive around the steps. And you have a lot of information in this home screen. And also for each of the different steps, there's a lot of more, if you click into those, kind of landing pages that explain what the service is used for. It gives you a quick intro and also shows directly all of the individual artifacts you might have already created there. So hopefully this makes it even more fun working with SageMaker here. Then a little bit more on the operational side, a lot of you have asked us for a way to schedule notebooks. And we do have that capability now. So you can now create notebook jobs from within SageMaker Studio. And that means you can see a screenshot here. You can grab a notebook, and whenever you define this, the tool will basically create a snapshot of your environment, and then you can schedule it to run the notebook maybe once or on a schedule, which probably makes more sense. And this is really kind of helping you, to kind of operationalize the notebooks and your environment. So you could do this to automate maybe some data prep jobs, or you want to run maybe a daily inference on some data to see how models are performing, etc. So this is now available. It's also available, by the way, in SageMaker Studio Lab. Then another part that many have asked for is how can we do better in giving you collaboration in Studio, meaning you want to work on a notebook maybe in the team, right, with a colleague. Maybe I want to create a demo. I want to have Chris look into that notebook, maybe also add some code. And you can now do this with Studio. So there's a functionality that's a shared space. And if you go set up your SageMaker Studio environment and click into the domains, the Studio domains, you can now also create spaces, shared spaces, simply create it, and then the users in that SageMaker Studio domain have access. So I could create a space and then collaborate, for example, with Chris in developing notebooks and work out of a shared directory there. You still have your personal spaces, but for this collaborative environment, this is great if you want to, work on notebooks at the same time. This is how it looks. So you also see, if I go in there, I see if anyone else is currently editing and working in this notebook. So it tags that, and you can see and follow any live edits within the same notebook here. This is kind of what we just briefly touched on, what Chris explained, the glue support for Ray and Spark. It's also available within SageMaker to make use of the glue interactive sessions. And the Spark integration is already GA. And now with the glue support of Ray, you can also, from within SageMaker, use the glue interactive sessions in preview for Ray. All right, you might have seen this when I showed the collaboration slide, not sure. As part of all of the enhancements to Studio, you can now also create more than one domain. In the past, it was limited per account to have one Studio domain, and now you can create multiple domains. So this is helpful if you want to, separate the Studio domains maybe for different teams and have their little space and their shared space there, and then also, if you want to isolate the resources. And then there's also now tagging. So SageMaker tags the resources automatically at a domain level. So with this multiple domain, you can use this in combination with the tagging. Maybe if you want to, have a better cost allocation as well. As like, hey, team A, those are the resources you're using. Team B, this is what they're using. All right, one more piece here from the SageMaker support on data. They also have now support for geospatial data. So if this is your use case, you're building a lot of ML use cases, it's now really integrated with SageMaker. What is geospatial? You see a couple of examples here. It could be aerial and satellite imagery, could be mapping data, and you can now, from within SageMaker, access geospatial data sources, and then, select or train a model on that data, and then also really cool here, visualize the predictions. So much better support specifically for geospatial ML. Chris, I think you worked with that team. Do you want to maybe say a couple of things about the improved SageMaker experiments?
Yeah, this was the other theme that I meant to bring up. This didn't actually come out the week of reInvents. It came out about a week or two after. But yeah, there's quite a renewed focus on SageMaker experiments. This comes a lot from customer feedback. The old experiments had some, issues with like the visualizations, things like that, even just the APIs. So yeah, quite a lot here. I think we have to move a little bit quicker. Maybe just kind of through. Cool.
All right, let's switch to the model deployment for inference. One thing I'm really excited about, one of the new things we can do now is shadow testing with SageMaker endpoints. So when you roll out your models, you want to test the models, you want to validate the performance, you can now have a managed experience for shadow testing. What that means is you can, let's say you have a model A that is in production, that is serving your inference request for a use case. You can work on a new version of this model, let's call it model B, and you can test that model, validate it by using a shadow variant that is receiving the live traffic. So you roll that out, it receives, and you can define how much percentage, for example, of the live traffic this model will see. And then you can see how the model performs in the real production environment. The importance here, the shadow testing means the new model does not reply back to the calling application or the calling, client. So it receives the inference requests and you can see what the results are, but only the first main, model A in this case will return to the client application. So this is a great way to validate new models, catch potential configuration errors and performance issues before you roll out. And when you see that the model is behaving as it should and it's a good performance, you can then promote that new shadow model to become, a production model that's serving traffic back. There's a lot of tooling that comes around with it, so I'm not going to go into detail, but obviously, you can set up tests for specific durations, monitor the performance through a dashboard, and that. All right, a couple of more things that came pre-invent, which means just, the week leading up to reInvent. We do have support for large models now that require larger volume size. I think up to then you could have like up to 30 gigabyte of EBS storage attached to the endpoints. And now you can have up to 500 gigs. So that enables, you to use and deploy larger models. And also we have a functionality called multi-model endpoint that gives you the possibility to serve thousands of models, and the endpoint just, dynamically loads the models that are needed into the memory. It was supported for CPU-based instances only. It's now supported also for GPU-based instances. Okay, one more section here on the low-code, no-code side of things. If you're looking into SageMaker Jumpstart, which is an ML hub that gives you access to models, to pre-built solutions, you now have the possibility to share your own models. So when you're creating models or notebooks, even models that are created maybe outside of SageMaker, you can now register them and you can share model artifacts within your AWS account with other teams. So you can contribute to that Jumpstart within your account. And then other, colleagues can, with a very easy way, deploy them from this environment. Jumpstart also added more models, super interesting. There's an Alexa teacher model now that Amazon Alexa AI team developed available. We have stable diffusion and blue models available, and also new TensorFlow text classification algorithms. And the team keeps updating those, so probably by now there's a couple of more models I missed on that slide. So feel free to check that. There's a great selection of foundation models now available, very easily for you to deploy and use through SageMaker Jumpstart. Then the other low-code, no-code environment is SageMaker Canvas, which is more targeted for kind of the business analyst type of persona who doesn't have much, knowledge or experience in machine learning. but wants to use, just grab a data set and click a button to have a model ready. So this is SageMaker Canvas. What you can do now is you can bring your own model. So let's say you have a very experienced ML team that's generating models. You can make your own model now available for your business analysts in Canvas. So you can register the model in your SageMaker environment. For example, if it's a model outside from trained somewhere else, you just register it in the model registry and you can share it with the Canvas users. Or if you're training in SageMaker, let's say in Autopilot, or you're working with Jumpstart, you can also from there share the model. And then the users in Canvas, as you can see here, get a little pop-up message that the model has been shared with them, and they can start using it to create predictions relevant to them. All right, another thing in the low-code, no-code, AutoML, which is SageMaker Autopilot, is now integrated with SageMaker Pipeline. So you can add this as a specific step in your SageMaker pipeline now as well. And this is pretty much what I had for today. Chris, anything you want to add?
No, yeah, lots of oh, did you talk about Code Whisperer?
I did not.
Oh, let's talk about Code Whisperer.
Okay, here we go.
Yeah, Code Whisperer, if you've heard of the GitHub Copilot project or product. So this is actually live, or not live, but this was a live screenshot from one of my hacking sessions with Code Whisperer, where you can actually generate code. So this is integrated with VS Code. You don't need SageMaker Studio or any managed service for this, except for Code Whisperer. The VS Code plugin plugs right in, and all you do is really just start typing comments. So 99.9% of this code was actually generated by Code Whisperer. All I did was hit the hashtag and start typing what in a comment what I wanted to do. This was Python, and this even worked with Spark. This worked with Matplotlib, it worked with Pandas, and was pretty incredible. The only thing I had to change was the actual data set, because it did not know which data set I was using. Also note that it sort of adapts to any code that was written before. So it kind of learns and understands the context of what you're trying to do, and it starts to get better and better. Antje, can you talk about the builder ID? That's really all you need to get started. You, do you even need a credit card to use Code Whisperer? Can't remember. I think you just have to create the builder ID.
Yeah, so the builder ID is a new concept AWS started. So what you can do, the builder ID is supposed to just for you, give you kind of a profile, a login based on your email address. So you can set up this builder ID for yourself. And then, as you maybe, change jobs, change companies, you're probably going to work with different AWS accounts. And the builder ID is really kind of your way to stick to your profile, even if you're working through different AWS accounts over the future with different companies, different purposes. Builder ID, you can just sign in with an email address. So usually it's I guess a personal email address you're choosing for that purpose. And that keeps track, like for example here, if you install Code Whisperer, you can connect it. Obviously have a linked AWS account, I think in that case, but again, you can update that part if that changes, but you still keep your profile with the AWS Builder ID. So in this case, yeah, with Code Whisperer, when you install the plugin, it will ask you to create a Builder ID, and then you can start using it.
And then did you show, I think it's a few slides before that, maybe the integration with many popular data sources? Data Wrangler now supports 40 data sources, including Databricks and EMR. Yeah, so this is a pretty big deal. It's not just S3 anymore. You could actually, with Data Wrangler, which is our sort of, way to build a flow for your data preparation to wrangle your data, you can now actually integrate with Redshift also, EMR, Athena, which gives you the ability to run powerful transformations on a serverless cluster as part of your flow. So that one's pretty neat. Got a chance to play with that one last week. And let's see, serverless EMR and serverless Redshift are now GA. That's pretty exciting. We're in a time currently where a lot of the like AWS services that have been around for a while are now starting to move to serverless. It's just a shift we've been seeing with a lot of services. I think even, isn't our managed Kafka now also serverless, I believe?
Maybe, yeah. Not sure.
Yeah. Better support for Iceberg throughout the entire like AWS product suite, service suite. That one's a big one. And I think, yeah, SageMaker experiments, pretty excited about that. There's support now for what's called warm pools within SageMaker training jobs. One of the common complaints about SageMaker training jobs is that they do take 4 or 5 minutes to start up. And so now you can actually specify a keep alive time and, you know, keep alive for 1 hour, and any subsequent jobs that you do after that, if they're hyperparameter tuning jobs, if they're autopilot, sort of auto ML jobs, they will start up within seconds because the actual infrastructure has already been provisioned. SageMaker pipelines now fully supports local mode. You can also share pipeline artifacts across multiple accounts. That was a question that actually came up on chat, sort of privately here. Multi-account strategy for SageMaker is getting better and better. There's a service called RAM, Resource Access Manager, I believe. It's kind of a bad acronym, RAM, but Resource Access Manager is it's an AWS separate service, and it's being used by a lot of different services to perform cross-account, which is not just an issue with SageMaker, but also across all the many services, which gives you the ability to kind of share between dev and test, or different lines of business that have isolated accounts. You can now share models across. Better GPU support for multimodal endpoints. I think you might have mentioned that.
Yeah.
And I think that's it. Yeah. And
All right.
I'll just link again to the deck.
Right. We do have a very extensive deck available. So if you want to, you know, follow up and have a closer look at what we announced today, was really kind of giving you a quick overview of the highlights here. Let us know if you're interested in one particular, and we can definitely dive deeper in one of the upcoming meetups.
And thanks again, Adi, for joining us. Great talk as always. Nice to see you. And buy the book. I just bought it. I'm sure Antje will too. And can't wait to see it when it comes out.
All right. Thanks everyone for joining.
Bye.
See you next month. Bye-bye.